The strategic objective of this university is to be research-led. We believe that the School of Engineering is making a significant contribution to the research. We have a number of chairs, research centres and groups which are doing really well, and at the moment our research productivity is at one of the highest, or at the highest it has been for a number of years.
School of Engineering is home of top-class engineers and researchers who used to provide solutions to the problems that are prevalent in the community through harnessing appropriate technology and processes to build an ecological environment and a prosperous nation.
Well, we have about 400 undergraduate students in mechanical engineering and another 75 or so postgraduate students. So about 19 to 20% of our students are doing research. So research is very important to us here in mechanical engineering.
Right now we're the only university in South Africa conducting rocket propulsion, and in Africa it's quite clear that we're leading any form of research activities. But we're growing very quickly, and that's a lot of thanks to the very good financial support we've received from government for our research activities. So we've already got two flagship projects as part of the Aerospace Systems Research Group. The first is the Phoenix hybrid sounding rocket program. And the whole idea there is to develop a series of sounding rockets that are able to service the needs of South Africa's and Africa's scientific community in terms of high altitude experimentation. And the second project right now is a Sapphire liquid rocket engine development program. And that is seeking to develop a series of liquid propulsion rocket engines to provide propulsion to a small satellite launch vehicle.
The Mechatronics and Robotics Research Group is presently involved in advanced manufacturing research. We are currently exploring how humans and robots can work together in a manufacturing systems. The idea is that robots do not replace humans in manufacturing environments, but rather remove the mundane tasks that they are currently involved with, making the manufacturing environment safer and more friendly towards humans, but still keeping the human involvement, thereby preserving jobs and upskilling people. A further thrust of our research group is the innovation and development of low-cost robotics for the South African market and also the African market at large. The National Research Foundation is presently funding much of our research into the development of unique robotic architectures.
The research from chemical engineering has a direct impact on the environment. Given the amount of industrial activity in South Africa, there are constant efforts to reduce the emissions and to do things in a cleaner, more efficient way, reducing the consumption of raw materials and impacts to the environment.
At the Thermodynamics Research Unit, we undertake phase equilibrium measurements, mostly for separation processes in industry. We have a large laboratory with many students and researchers. We also have a division which looks at computer simulations and modeling of chemical processes. We have developed a process that extracts rare earth metals from luminiferous powder. The luminiferous powder is a product from the lighting recycling industry, and the rare earth metals that we extract can be sold for reuse in industry.
The Pollution Research Group concentrates on water and sanitation. We work very closely with the eThekwini municipality, and through that the Water Research Commission of South Africa. Primary funding, of course, comes from the Bill and Melinda Gates Foundation. Another interesting project that we're working on is the analysis of the Ascaris eggs. We have a team of people that are looking at the analysis of Ascaris because it is the pathogen that we have of major concern, and we need to be able to assess different technologies for their efficiency in deactivating these worms. We have a project in conjunction with our partners in crop science, and that's looking at the recycling of nutrients from urban areas to rural areas. And that project is being done in conjunction with 4 other African universities.
The major breakthrough in 2018 for us was to be awarded the prestigious South African Research Chair Initiative, a recent project that we are running on sugarcane wax. You can extract wax from the sugarcane rind, and this can be used to substitute other waxes in high lifestyle products or cosmetics, pharmaceuticals.
We wouldn't be able to do research without funding. It's really important. It's the driving force to keeping a lab up to date. In particular, I'm very appreciative, and many of my staffers, for the Eskom Test Fund. Other important funding is Telkom, and then international funding as well, such as Newton Fund. Very important, and we wouldn't be able to do our job if it wasn't for these funders. Recently, one of our researchers have received Newton funding for a superconducting flywheel. So there's lots of interesting stuff going on.
Then I think one day that double gate MOSFET is working. Double gate MOSFET means we have the gate on the both side of the transistors. Then I was simply thinking that how I can make it new. Then the idea comes into my mind at that time that if we will rotate this MOSFET, means we will make the gate all around the substrate. Then we will get the more functionality, so it will be better. And this cylindrical one will take very few space in the mobile. At present, we are not fabricating this one. We are at the simulation and designing process.
The power line inspection robot rolls along power lines and transmits data to a ground station. This data is used for inspection of those power lines. The special thing about the robot is that it can climb past obstacles on the line, and it can also climb past towers. In terms of technical breakthroughs, we're using new materials for the structure of the robot, namely carbon fiber. We're also now building our servo motors from the ground up using custom electronics. We are also on the software front using machine learning, artificial intelligence techniques to identify objects in the robot's environment. The technology has been patented in several countries, including South Africa, the United States, and Canada. The funding has really helped us to develop the technology from research to a product. So every successive prototype is an improvement over the previous one.
Welcome to the Smart Grid Research Building. This houses the official UKZN Centre for Power and Energy Systems. This project is basically about battery storage for rural areas. What we've got is different types of batteries buried in the ground here, and a battery in the rim back there. Those are connected to a charge controller, which is connected to the photovoltaic panels. Basically, we're looking at the cycling of the batteries and trying to determine what's the best way to store them for a rural home. What's nice about the project was that we got given some very, very good quality equipment, so we can monitor it online the whole time. The benefit of the project is that you can provide a rural home with electricity when it's not even close to a distribution line.
The research in my cluster is a little bit diverse because it's a quite large cluster with 4 programs. So we have various research activities. Because of the diversity of the research, the value, although high, it differs in its impact. The main research entities are in civil engineering and bioresources engineering, not to forget mentioning the research happening in the land surveying and construction studies as well. The Transportation Research Group is a multidisciplinary group where we look at different aspects of transportation. I can mention 2 very important ones. The first one is trying to introduce a new design for traffic lights, while the other one is introduction of asphalt and pavement materials which are made of recycled or byproducts, and these are normally much cheaper than what is in the market already.
This is the Environmental Engineering Laboratory based in the Department of Civil Engineering. We are part of the South African Chair in Waste and Climate Change that is based here at UKZN. A lot of our innovative projects revolve around the use of waste or diverting waste from landfill and using that waste in projects that produce value-added products. Some of the projects we're involved in is alternate building materials, where we use waste products such as biochar, waste tires, and organic waste in construction materials. One of our very interesting projects that we're involved in is the Neptune project, which is being used to create awareness about waste, in particular plastic waste. And the idea behind the project is to use plastic waste in the creation and promotion of art. Some of our external collaborators and funders include Saneri, Lotto, TRIP, DTI, DSW, and NRF. These collaborators and funders have helped the advancement of many of these projects, as well as allowed capacity building in terms of research outputs, as well as PhDs, masters, and undergrad students that have graduated.
So this is the Environmental Fluid Mechanics Lab. Here we look at trying to address complex engineering flows and develop design solutions for them. So projects that we're working on currently are the hydrodynamics underneath breaking waves, to look at how sediment moves on or offshore along our coastline. We have some renewable energy projects where we are trying to produce biofuel from wastewater discharges in flexible tubes, as well as flying kites in the Agulhas Current to extract energy from the Agulhas Current. The research here is primarily sponsored by eThekwini Research Chair Funds. The results of this research are used directly in shore protection along specifically our Durban coastline, making sure that there's sand on the beaches or figuring out why there isn't sand on the beaches.
Our group is the Structural Engineering and Computational Mechanics group. Recently we completed 2 studies. The first was related to the structural evaluation of megalithic monuments in Malta. These are monuments that have been constructed the 4th millennium before Christ. So they are in the UNESCO's World Heritage List, and we completed the study and we published in a top engineering journal our results. And the second study was related to graphene and non-composite materials. So the materials and structures of the past and the materials and structures of the future.
Bioresources Engineering at UKZN have been working with the forestry industry in South Africa and collaborating with the Institute for Commercial Forestry Research, Forestry South Africa and the Department of Science and Technology to provide affordable and appropriate mechanical assistance to small-scale timber farmers, and thus reduce their hard manual labour required when harvesting their timber and also improve their productivity during harvest. The Mgeni Water Chair has been involved in supporting a number of research projects which range from the role of ecological infrastructure in securing water supply in the Mgeni catchment, research on fish behaviour monitoring techniques, development of a predictive mass balance model of chlorine and flocculant consumption in water treatment systems, development of a predictive mathematical model of revising and updating techniques in water treatment, to leading the National Flood Studies Program in South Africa, which is revising and updating techniques for flood estimation in the country.
The open-ended, naturally ventilated greenhouse does not need external energy to run. However, in terms of temperature and relative humidity management, it works perfectly, and there is no significant differences between productivity between this greenhouse and that which requires electricity grid to run. In one of our recent research, we integrated solar energy into low-cost evaporative cooling technology. So now the system is running totally with solar energy. The technology can be implemented in a remote area outside electricity grid.
This is a master's level project. We're looking at vertical farming and soilless media culture. So we want to see the performance of vertical farming and soilless media, but also comparing it to the productivity of ground-based or traditional growing methods. We're looking to see the productivity, water use efficiencies, things like that. We're running with artificial light and with natural light, and then we also have 2 different nutrient concentrations to see the nutrient use efficiencies as well. We're hoping that this will help revolutionize farming and help people with small-scale agriculture to be more productive on their land.
School of Engineering looks forward to more collaboration with industry, government and community partners for producing research outputs that will have direct impact on the community to change people's lives while maintaining the world-class quality and standard.
We're well aware that South Africa is a unique country and the needs are unique in terms of what's required. A number of the projects, both in the research centres and the scholarships, require us to meet the needs of society, and we have done a lot of work in that direction. We are pleased with this and we believe that in the future we'll continue to be growing.